Welcome back to Math Concepts. In this video we are going to discuss some further examples of using Venn diagrams. We're going to talk about situations where you have three sets in the mix and how you can draw the Venn diagrams for those. And we're also going to discuss how we can use Venn diagrams to determine when two sets are equal. Okay, because sometimes the sets might look like they're different, but they actually end up representing the same thing. And there's a way to use Venn diagrams to figure out when that's happening. So let's go over to the document camera and look at those examples. Okay, so in these examples we will draw the Venn diagram for each set. Let's start out with a simple one here, A intersect B intersect C. Okay, so remember when we're doing a Venn diagram we always want to start with a box. And that box represents the universal set. Okay, now we're going to need that because we might be dealing with complements. We're not here, but we might be in other examples. And you'll have to shade the outside. So you'll need that box for the outside shading. Now we have three sets involved, so we're going to need three circles. Circle for A, circle for B, and circle for C. Okay, now when you're doing this, make sure you label all your sets involved in the Venn diagram. So what we're going to do is we are going to shade this set, and when we're talking about intersection, we remember that intersection means overlap. So we're talking about the region that is where A overlaps B, and that overlaps with C. So we're talking about something that is in common to all three sets. So it'd be that region right there. Okay, so that's the Venn diagram for A intersect B intersect C. I want to do a couple others just so we get some practice. Okay, let me try this. Let me try a couple different operations for this one. Let's do A intersect B union C. Okay, so once again, draw my box. Circle for A, circle for B, and a circle for C. And I'll label them A, B, and C. That's my universal set. All right, now, as before, I'm going to do a little bit of scratch work here. Remember, the parentheses tell us what to do first. So I'm going to draw that Venn diagram first. So this is for scratch work. So in the parentheses we've got B union C. So we're going to take the set B together with the set C. Okay, remember union means you're taking the two sets and combining them into one big set. So that's B union C. Now we got to overlap that with A. Okay, so we're looking at where does the region that I've shaded here, where does that overlap with the circle for A? And it's not hard to see that the overlap is right there. Okay. So let me do another one. Let me do one that is kind of like that. But I'm going to change one little thing. Okay. So here we're going to do A intersect B and then union with C. So the thing I've changed between the two problems is I have changed where the parentheses are. And it'll be interesting to see whether or not that makes a difference in the final answer. So once again, I'm going to do some scratch work over here. Okay, so first thing I want to do is shade A intersect B, and that's where A and B overlap. All right, so that's right there. Okay, now for the problem, I'm supposed to do a little bit more than just find A intersect B. I'm supposed to take A intersect B and then put that together with C. So remember, an intersection usually gives us a smaller set than either of the sets we started with, and a union typically gives us a bigger set. So I'm going to take A intersect B, and I'm going to throw in everything in C. All right? So now I get this right here. And notice that this is different from the set that I have up here. So these sets are not equal. And I can tell they're not equal because they have different Venn diagrams. Okay? Oh, that's really sloppy. Whatever, you get the idea. Okay. But that's an important point. Okay? Two sets are equal if they have the same Venn diagram. Two sets are unequal if they have different Venn diagrams. So if you run into a question that's asking you whether or not two sets are equal, draw their Venn diagrams. If they have the same Venn diagram, then the sets are equal. If they have different Venn diagrams, then the sets are unequal. Okay, so let me just make some note about that. Same diagram equal sets. Different Venn diagrams then you have unequal sets. Let me look at a quick example here of two things that might look like they're unequal, but they actually turn out to be the same. Okay, I'm going to draw Venn diagrams for A union B complement. And then I'm going to draw the Venn diagram for A complement intersect B complement. Okay, now here I've gone back to dealing with just two sets, so I only need two circles in my Venn diagram. Okay, and I want to be able to show you both of them simultaneously. So in both cases I will have a box representing the universal set. Okay. Down here is where I'll put some scratch work. Don't be afraid to do scratch work when you're making these Venn diagrams. It can be very helpful. Okay. Okay, so this is the Venn diagram for A union B. Alright, now the reason I did that is because I'm following the parentheses. Inside the parentheses is what we do first. Find A union B, then take the complement. Okay, so this is the Venn diagram for A union B. And I want the opposite of that. That's what complement means in Venn diagrams. Whatever is shaded, when you do the complement, it won't be shaded. If something isn't shaded when you do the complement, it will be shaded. So what we have here is the outside of the circles, the stuff that's outside both circles. Okay, now let me do some scratch work for this one. We're going to do A complement, figure out what that would look like. Then we're going to do B complement, and then we're going to intersect the two of them. A complement would be everything outside the circle for A, so it's all this. B complement would be everything that's outside the circle for B. So it's all out there. Now, that's A complement, that's B complement. Now, I want the overlap of these two. In other words, the stuff that is shaded in both. So in other words, this won't be shaded because it's not shaded here. This won't be shaded because it's not shaded here. The only stuff that's shaded in both diagrams is the outside of the circles. So there's my Venn diagram for A complement intersect B complement. So these two, even though the expressions for the sets look a little bit different, this involves union, this involves intersection, they actually end up being equal sets, and we can tell that because they have the same Venn diagram. So a very useful tool for determining whether sets are equal.